This is an example for Algebra 1, Unit 6, Lesson 3 on page 197. I had a question about number 38. However, since that is one of the assessment questions, I'm going to do one that is similar. Not exactly the same, but very similar. So we're going to start off with a question. 16x cubed plus 24x to the 5th power plus 8x squared. The problem asks you to use factoring to evaluate the equation. So basically we want to factor what we can out of each term in this equation. When you're factoring, remember, you want to look at each term, and by term I mean each set, the number and the variable. Each one of these is a term. Okay? We're going to look at each term, and we're going to look at the numbers, and then we're going to look at the variables. Okay, so looking at the numbers first, what we're looking for in those numbers is, do they all have a common factor? Is there something that I could divide out of each one of those? Or can they all be divided by the same number? So that's what I'm looking for. I want to see what number could I divide out of all of those. Hopefully you can easily see with 16, 24, and 8, they all can be divided by 4. So 4 is what I'm going to divide out. When you're factoring, you're dividing things out, taking them out. So I take the 4 out to the front, all right, and we're not doing the x's yet, so I'm going to leave a space right here for the x. And again, I'm just looking at the numbers. So if I divide 4 out of 16, I'm dividing, remember. 16 divided by 4 is going to leave me with 4. I'm going to leave a space there because we didn't deal with the x yet. 24 divided by 4, if I take 4 out, is going to leave me with 6. Again, I'll leave a space for whatever x might be there. And in the last one, 8, if I divide 4 out, what's remaining is 2. Again, remember, I'm dividing that out. Okay, so that's the numbers. Now I look at the variables. When I'm looking at the variables, first of all, to factor them, they all have to be the same variable. Okay, they don't have to have the same exponent, but they all have to be the same variable to factor. These all of these terms have an x, so I can factor out some x's. The number of x's I factor out has to be the same for each term. Okay, so I cannot factor out, for instance, this has 5. I can't take 5 x's from all of these terms because they all don't have 5. This only has 2 x's. This only has 3. So I can't take 5 x's from this one, 5 x's from this one, and 5 x's from that one because they're just not there. So I have to take out the most that I can from each one. It's got to be the same amount, but the most I can from each one. If it helps, sometimes I write it out. X squared is really x times x. X to the 5th is x times x times x times x times x. X times itself 5 times. X to the 3rd is x times itself 3 times. All right? This hopefully allows you to see more clearly that the most I can take out of each one is 2, because this one only has 2. So that's all I can take from that one. So if I take 2 from this one, 2 from this one, and 2 from this one, all right? So now I take that outside, just like I did before. I'm dividing that out. I have x squared outside because I took, remember, x squared is x times x. That's the 2 x's. What's remaining in my first term? Look here. I took out the 2. What's remaining is just 1x. What's remaining in the second term? I took out 2. What's remaining is x, 3 x's, or x cubed. X to the 3rd power. What's remaining in the last one? Well, I took out 2. There's no more x's. So I'm just going to move that parenthesis up. That's all there is. Okay? So now looking at problem number 38, 22y squared, minus 33y cubed plus 11y squared. Same concept. I'm not going to do it because it's an assessment question, but look at each number, see what you could divide out of all 3 numbers, then look at your variables, see how many variables you can take out from each one. I hope this helps.